Hello viewers, I'm Kausalya. Today we are going to discuss about AC parallel circuit. So what is mean by parallel circuit? The starting and ending point of an element is similar to that of the starting and ending point of another element, right? So when impedances are connected in parallel and the combination is excited by an AC source, then it is known as AC parallel circuit. You see, in this diagram, Z1 and Z2 are parallel and they are connected across an AC source, right? So this type of circuit is known as AC parallel circuit. So here we are using admittance method to find the parameters. So what is mean by admittance? Admittance is nothing but it is the reciprocal of impedance. So admittance symbol is Y here. So Y is equal to 1 by Z. So by normal formula, what is the formula for V? V is equal to I into Z, and here I is equal to V by Z. And just now we had find out, right, 1 by Z is Y. Therefore here 1 by Z is replaced as Y here, right. The unit is Simon or mho and this is your symbol, right. Now look at these impedance triangles, right. So here this is your R and this is your XL and this is your impedance Z and this is your angle pi, right. And here in this case you see here it is G and it is B and here this total is Y, right, and this is your phase angle pi here. So G is nothing but conductance and B is nothing but your susceptance, right. So when you observe from this diagram, cos pi, okay, how to write cos pi? Cos pi is nothing but adjacent by hypotenuse. So this is your adjacent side G and this is your hypotenuse Y, right. So just write down the expression. So from this, write down the value for G here. So G is given by Y into cos pi, right. What is meant by Y? Y is nothing but 1 by Z. And again, this cos pi, you see, we are referring this triangle. So cos pi can be written as R by Z from this triangle, right. So here cos pi is equal to R by Z and finally here the answer is R by Z square, right. Next we are proceeding with the susceptance. So for calculating susceptance, we are considering an RC circuit. You see this is your R, right, and this is your XC and here the summation gives the impedance Z and this is your pi. And here similarly this is your G, this is your B and this is your Y and this is your pi, right. So susceptance is given by the expression sin pi. So sin pi is nothing but opposite side by hypotenuse. So what is the opposite side? B is the opposite side and Y is the hypotenuse, right. So just write down it. Sin pi is equal to B by Y and B is nothing but Y into sin pi. So what is meant by Y? Y is nothing but again 1 by Z. And what is your sin pi? Again you have to look at this impedance triangle. So again sin pi is given by X by Z, right. So here it is written as X by Z and finally B is given by X by Z square, right. So here in this case you see the conductance is always positive, right, whereas susceptance is positive for capacitive reactance and it is negative for inductive reactance. You have to keep these things in your mind while solving the problem, right. And the next one is there are some steps to be followed for solving the problem, right. So assume that this is the typical model of a problem, right. We are having RC and we are having RL here. So we are naming it as R1 C1 and here R2 C2 and current flowing through this branch is I1 and current flowing through this branch is I2, right. So here you see if the C1 and L2 are given, right, you see C1 and L2 are given, the first step is we have to calculate the capacitive reactance and capacitive inductance, right. Capacitive reactance is given by 1 by 2 pi f C1 And inductive reactance is given by 2 pi f L2, right? And this is your first step. And the second step is calculating the total impedance and phase angle. So here you see, let this be your impedance Z1 and these two constitute Z2. So Z1 is given by square root of R1 square plus XC1 square, and Z2 is given by R2 square plus XL2 square, right? And pi 1 is nothing but tan inverse of XC1 by R1, and here this pi 2 is nothing but tan inverse of XL2 by R2, right? So these are all the basic steps to be done. And the next thing is we have to calculate the conductance, susceptance and admittance for both the branches. First we are doing for branch 1. So this is given by G1 is equal to R1 by Z1 square and B1 is XC1 by Z1 square, right? And Y1 is given by square root of G1 square plus B1 square. And the next thing is calculate the conductance, susceptance and admittance of branch 2, right? So here G2 is given by R2 by Z2 square and B2 is XL2 by Z2 square. Since here it is inductance, the value of this susceptance is negative. And Y2 is given by square root of G2 square plus B2 square. Total conductance G is nothing but G1 plus G2. And total susceptance B is given by B1 minus B2, right? And total admittance is given by square root of G square plus B square. And here again the branch currents are calculated as, you see, I1 is nothing but V into Y1, I2 is V into Y2 and I is nothing but V into Y. And the phase angle of the whole circuit, okay, it is calculated by tan inverse of B by G, right? You see here we have already calculated B and G. So you see pi is given by this formula. So this is said to be lagging if the value of B is negative. And finally power factor is given by cos pi is equal to G by Y, right? These are all the steps which are important to solve a problem in case of RC parallel circuits, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.